Dear students, we will see ARM processor and peripherals. So first we will see the introduction to ARM processor. So popular manufacturer of this ARM are Maxim Integrated Analog Devices, and you can see the microchips. So what is ARM? It is nothing but Advanced RISC Machine. What is RISC? Reduced Instruction Set Computer. So ARM is Advanced RISC Machine. A or M. A stands for Advanced or RISC and M stands for Machine. So that is founded in 1919. So it is owned by Acron, Apple and VLSI. It is a 32-bit RISC processor. So first RISC processor mainly used for the commercial use. So it is used for mostly it is used portable devices because power consumption is very low. So this ARM is a 32-bit architecture, a 60-bit architecture in V8. So up to V7 it is 32-bit architecture. After V8 it is a 64-bit architecture. When used in relation to the ARM, we have to know what is byte and what is half word and word. Here the byte means 8-bit, half word means 60-bit, that is 2 bytes. Word means 32-bit, that is 4 bytes. Here we are using 32 bits. We may use a byte, half word or word in our ARM processor. Most ARM processors implement two instruction set. One is a 32-bit ARM instruction set, another one is 16-bit thumb instruction set. Okay, here the Jesila codes also used for executing the Java bytecode. Generally, it has two instruction set. One is 32-bit ARM instruction set and 16-bit thumb instruction. But for the Java bytecode, we are using Jesila codes. So now we'll see the difference between RISC and CISC. What is the RISC? It is a reduced instruction set computer, and the CISC complex instruction set computer. So the RISC, it is software to optimize the instruction set. It is emphasized, CISC is emphasized a hardware to optimize the instruction set. RISC is hardware unit of programming in a RISC processor. Microprogram unit is CISC processor. So RISC has simple decoding of instruction. CISC has complex decoding of instruction. The RISC has a simple pipelining, but CISC is a difficult. Pipelining is difficult. It is used for the less number of instructions. That's why it is called a RISC reduced instruction set computer. It is here the CISC is a large number of instructions. So in a RISC, less time to execute the instruction, but the CISC is longer. Okay. The RISC architecture can be used with high-end application. Mainly, it is used in telecommunication, image processing, video processing. And CISC architecture can be used for low-end application like home automation, security system, etc. In a RISC, it is a fixed format instruction, but here the CISC is variable format instructions. Here the RISC architecture, it requires more space. That is more space in memory. But the program written in a CISC architecture has less space in memory. So we can say the RISC is ARM, and similarly for the CISC is Motorola 68000 families. So now generally in a computer architecture we have two architectures. One is von Neumann architecture and another Harvard architecture. So von Neumann is what is the difference between these two? It is von Neumann have only one memory for the address and data, but here the Harvard requires two memories. One is for data memory and another one is a program memory. So now we can see the ARM nomenclatures. The ARM X, Y, Z, T, D, M, I, E, J, F, S. So X stands for family, Y for memory management, and Z for cache. T is a thumb 16-bit decoder. D is a J debug. Okay, and M is a fast multiplier. I represent embedded IC macro cell, and E enhanced instruction set, and J Jesila. F vector floating point. S is a synthesizable versions. So now we can see the versions. ARM V1, that is version 1, it is a first version, 26-bit addressing. It don't have any multiply or coprocessor. V2, it is a first commercial chip. It has a 32-bit result multiplying instructions, and it has a coprocessor support. And in the version A, that is V2A, that is ARM3 chip or on-chip cache, added a load and store instructions and a cache memory. We will see later what is load and store. And ARM V3, it is ARM6, that is 32-bit addressing. It will support the virtual memory also. So ARM V4, let us consider ARM7 TDMI. So we'll see what is here. It is, you can see here, T represent thumb, that is 16-bit instruction set. D represent on-chip debugging support. It have enabling the process to halt in response to the debug request. And M is for enhance the multiplier, and it yield a full 64-bit results high performance. And I represent embedded IC hardware. So we can see ARM7, ARM7 or V7. There is it has a thumb 2, mixed 16 and 32-bit instruction is there, and ARM Cortex implementation is right. And we can see here the family comparison, ARM7 and ARM9, ARM10 and ARM11. The ARM7 pipe length is 3 stage. What is 3 stage? Yes, fetch, decode and execute. Okay, so here ARM7 5 stage. So ARM10 it has a 6 stage, and ARM11 8 stage. You can see this frequency 80 megahertz. Then here it is a 150, and there ARM10 is 260. Then we can here, you can see here losses here. It is losses, you can see here 0.97 for ARM7. Here you can see ARM9 is 1.5. Here ARM10 is 1.3 and ARM11 is 1.2. So here ARM7 up to ARM2 architecture is one human. So ARM9 and ARM10 and ARM11 are Harvard architectures. So multipliers, it has 8 cross 32. So then ARM10 is 16 cross 32 and ARM11 is 16 cross 32. So you can see that features, it is a load store architecture. I already told you that ARM processor is a load store architecture. It has a fixed length 32-bit instructions. It has a 3 address instruction format. You can see here the source 2, source 1 and destination and output. So each address field to specify either the processor register or the memory operand. You can hear the add R1, R2, R3 means this is source, R3 is a source 2, R2 is a source 1, destination R2, where the R1. So R3 add R2, R3 and stored in the R1. Okay, it is high core density. So it is 30. I told you that 32-bit architecture till V7. For V8, V8 from V8 is 64. Okay, so it is consistent 32-bit processor across the all architectures. So I told you that load architecture. It is ARM7. ARM7 is a load store architecture. So only load and store the instruction, access the memory. All other instruction use a register as an operand. Here you can see LDR R0, R1. That is R1 data is transferred to R0. That is load the data from R1 register to R0. Here the next one is add R0, R1 and R2. What is R2? R2 is a source 2. R1 is a source 1. Here we have to store the data. The add is the output. So that store the data R1, R2. The data stored in the R0. So the only operation which apply to the memory are that copy memory values into the register. That is, we are loading the instruction, or copy the register value into the memory, right? So that is store the instructions. That's why it is called as a load store architecture. So we can see here the ARM processor application. These are some of the ARM processor applications in our mobile phones, and you can see cameras, all the entertainment devices. They are using ARM processor only. Thank you.